India's semiconductor ambitions are gaining momentum, with a new report projecting massive growth in the country's chip market over the next decade as global supply chains shift and demand for electronics surges.
What if the next giant in semiconductors is not a place the world usually names first? Across India, government-backed chip projects are rising fast, and if they work, they could pull part of the global supply chain toward an entirely new center of power. The country that stayed out of the chip race is finally stepping in. For a long time, India was close to the semiconductor industry, but it was never fully inside it. The country designed chips, bought huge numbers of chips, and built a large electronics market, yet most of the world's chip manufacturing stayed somewhere else. Now that is starting to change. India has begun pushing hard to build its own semiconductor base through the India Semiconductor Mission. This push is not small. It includes chip fabs, packaging units, assembly, testing, and other parts of the supply chain that are needed to make the industry work in real life. This matters because semiconductors are now part of almost everything. They power phones, cars, telecom systems, factory machines, defense equipment, data centers, and AI hardware. When chip supply gets disrupted, the effect spreads fast across industries and across countries. That is why India's move matters. This is not just about entering a new business. It is about trying to become part of one of the most important industries in the modern world. And once a country decides to do that, the real question is no longer ambition. The real question is whether it can actually deliver. The government built the launchpad before the factories arrived. Semiconductor factories are not easy to build. They need massive funding, long-term planning, clear policy, and strong confidence from investors. India understood that before trying to attract major chip projects, it had to make the environment more serious and more stable. That is where the Semicon India program and the India Semiconductor Mission became important. The government created a support system to make these projects more possible. Under the modified scheme, India offered up to 50% fiscal support for semiconductor fabs and up to 50% capital support for compound semiconductor, ATMP, and OSAT facilities. In simple words, the government did not just announce big goals. It put money behind them. That changed the picture. Building semiconductor facilities in India started to look less like a risky idea and more like a real industrial opportunity. Once that foundation was in place, India was no longer just talking about joining the chip race. It was building the conditions that could finally bring major companies in. And that is the moment when this story starts to move from policy into action. Dholera is where India wants to make history. In Dholera, India's semiconductor dream starts to look real. This is where Tata Electronics, working with Taiwan's Powerchip Semiconductor Manufacturing Corp., is building what India has presented as its first major semiconductor fab. The project is backed by an investment of about 91,000 crore rupees and is planned to handle 50,000 wafer starts per month. That number sounds impressive, but the deeper importance is what this factory is meant to do. A fab is not a normal factory. It is the place where silicon wafers go through highly controlled steps to become chips. The work is complex, the standards are extremely high, and even small mistakes can cause major losses. The Dholera fab is expected to focus on high-performance compute chips using 28 nanometer technology, along with power management chips, display driver chips, and microcontrollers. These are not symbolic products. They are used in phones, cars, displays, industrial systems, and many everyday electronics. That means this project is tied to real demand, not just national pride. More importantly, Dholera gives India something it has lacked for years: a serious manufacturing anchor in the chip industry. It turns the conversation from plans and policy into physical infrastructure. And once a fab like this begins to take shape, the story naturally grows bigger, because one plant alone cannot carry an entire semiconductor future. But a fab is only the beginning of the story. A fab is a major step, but it is only one part of the semiconductor chain. Making wafers is not the same as delivering finished chips to the world. After fabrication, chips still need to be assembled, tested, packaged, checked for quality, and moved through a wider industrial system before they are ready for real use. That is why India's semiconductor push is larger than the Dholera Fab alone. The country is also investing in the stages that come after fabrication. These include assembly, testing, packaging, and other downstream processes that are needed to turn chip production into a working supply chain. This part matters because no strong semiconductor ecosystem can depend on one headline project. It needs different facilities doing different jobs, skilled workers who understand each stage, suppliers that keep operations moving, and supporting industries that grow around the core plants. So the real story is not just that India is building a fab. The real story is that India is trying to build an ecosystem. And if that ecosystem becomes strong enough, then the country will not just have one impressive factory. It will have the base needed to support a much bigger role in the global chip industry. Micron brought the first big proof that India could actually do this. Big plans sound powerful, but they feel very different once something real starts operating on the ground. That is exactly what Micron changed. In February 2026, the company marked the opening of its semiconductor assembly and test facility in Sanand, Gujarat. It became the first facility of its kind in India and gave the country an early piece of real proof that this semiconductor push was moving beyond ideas. This facility takes advanced DRAM and NAND wafers from Micron's global network and turns them into finished memory and storage products. Once the first phase is fully ramped, the site is expected to include more than 500,000 square feet of cleanroom space. That makes it one of the world's largest single-floor assembly and test cleanrooms. What makes this important is not only its size, it shows that India is becoming a place where real semiconductor work can happen at scale. Real workers are being trained. Real products are moving through cleanrooms and testing lines. And because memory and storage are used in everything from data systems to AI infrastructure, this facility connects India to larger global technology flows. Micron's project also changed the mood around India's semiconductor story. Before this, many people could still treat the country's chip ambitions as a future possibility. After this, it became harder to dismiss them. India was no longer asking the world to imagine what might happen. It was showing that a major global company had already started building a serious operation there. Then, the rest of the network started locking into place. One successful facility can begin a story, but a wider network is what makes the story stronger. After the major announcements in Gujarat, India's semiconductor push started spreading into more projects, more partnerships, and more parts of the value chain. That matters because strong supply chains are not built around one site alone. They become stronger when work is spread across multiple locations and multiple specializations. One major example is Tata Electronics' semiconductor unit in Assam. According to the Indian government, this project carries an investment of 27,120 crore rupees and is designed to use indigenous semiconductor packaging technologies with a production capacity of 48 million units per day. That gives India another large semiconductor node beyond its flagship fab. Another important project is CG Power's Gujarat unit, built in partnership with Renesas and Stars Microelectronics. This project has an approved investment of 7,584 crore rupees and a planned capacity of around 15.07 million units per day. It is designed to support a wide range of packages for sectors such as automotive, consumer electronics, industrial systems, and 5G. Keynes adds another layer to this growing structure. Its approved Gujarat unit involves 3,307 crore rupees of investment and is meant for wire bond interconnect and substrate-based packages, with capacity of more than 6.33 million chips per day. When all of these projects are viewed together, the picture becomes much clearer. India is not making one giant bet and hoping everything follows. It is building several connected nodes that can support each other and reduce risk. In the semiconductor industry, that kind of spread is not a luxury. It is part of what makes the entire system more reliable. This is really about breaking a dangerous dependency. The deeper meaning of India's semiconductor push is not just that it wants to make chips. It is that the world has become too dependent on too few places for something this important. Semiconductors are now built into modern life so deeply that when supply chains tighten, the damage spreads quickly. Cars get delayed, electronics production slows, factories wait for parts, and whole industries feel the pressure. That is why India's role matters beyond its own borders. The country is not presenting itself only as a new manufacturer. It is also presenting itself as a more trusted partner in a global supply chain that many governments and companies now want to diversify. This gives India's projects a larger meaning. They are part of a wider effort to reduce risk in one of the most critical industries in the world. India Semiconductor Mission 2.0 also shows that this effort is not limited to adding a few factories. The next phase is meant to strengthen equipment, materials, Indian intellectual property, and the supply chain around semiconductor production. That makes the strategy much broader and more serious. So this is not only about local manufacturing, it is about giving the global chip system another major base of operation. And if India can do that well, it will help reduce a dangerous level of concentration that has shaped this industry for years. The real prize is not just chips, it is control. Countries do not invest in semiconductors only to make hardware. They do it because chips shape power in many other sectors. Semiconductors affect telecom networks, electric vehicles, defense systems, industrial machines, consumer electronics, and the AI servers driving the next phase of computing. Once chips become this central, depending too much on outside suppliers starts to look like a serious weakness. That is why India's real prize is larger than the chips themselves. If the country can build fabs, assembly lines, packaging plants, supplier networks, and skilled technical teams, it gains something much more valuable: control. It gains more influence over how fast its own industries can grow, and more strength in a world where semiconductor access is becoming more strategic every year. India does not need to dominate the most advanced chip nodes right away to benefit from this. Even strong capability in packaging, testing, memory-related operations, power electronics, display drivers, and mature node manufacturing can improve its position in the global system. That is the real turning point. Once semiconductor production starts supporting the wider economy, India is no longer only buying the future from somewhere else. It starts helping build that future itself. And that is why the next challenge matters so much. Because in semiconductors, building capacity is hard, but maintaining it is even harder. The hard part starts after the announcements. This is where the story becomes more difficult and more real. Announcing a semiconductor plant is one thing. Running it well, year after year, at high quality and high volume is something much harder. Semiconductor manufacturing is one of the most demanding industries in the world. It needs clean rooms, highly precise tools, stable supply lines, trained engineers, and strong process control every single day. India's policy direction now reflects that challenge. The country is not only talking about factories anymore. It is also expanding its focus toward materials, equipment, research, and workforce development. That matters because chip manufacturing is not built by buildings alone. It depends on people, systems, and long-term discipline. The talent issue is especially important. In March 2026, the government said students in 315 academic institutions were already getting exposure to semiconductor design, fabrication, packaging, and testing, and that this effort under ISM 2.0 is expected to expand to 500 institutions. That shows India understands that the success of this industry will depend on whether enough skilled people can support it over time. The early projects also show how careful this process must be. Tata Electronics' partnership with PSMC is not only about equipment, it is also about bringing advanced skills, supplier links, and ecosystem support into India. Micron's Sanand facility has already started commercial production, but it is ramping in stages, moving gradually from tens of millions of chips in 2026 toward much larger output in 2027. That is how this industry works. It moves step by step, with very little room for error. India has clearly opened the door, but the harder test starts now. The country still has to prove that it can build depth, train enough people, maintain quality, and turn big announcements into lasting performance. If this works, the global chip map will never look the same again. When all the pieces are brought together, the scale of the effort becomes hard to ignore. India now has a 91,000 crore rupee fab in Dholera, a major Micron assembly and test facility in Sanand, a large Tata packaging unit in Assam, and more approved semiconductor projects in Gujarat adding packaging, testing, and specialized chip capacity. This is no longer a single announcement. It is the early shape of a real semiconductor manufacturing network. That is why this story matters far beyond India. If these projects ramp successfully, India will no longer remain only a huge buyer of electronics. It will become a more important place where chips are fabricated, assembled, tested, and prepared for industries around the world, including automotive, telecom, consumer devices, computing, and AI-related infrastructure. India may not lead the most advanced nodes immediately, but that does not mean the impact will be small. Even strong capacity in mature node manufacturing, packaging, testing, and related areas can shift weight inside the global supply chain. The biggest change may also be the simplest one. For years, the chip industry looked fixed, as if the main centers of power were already decided. India's new projects challenge that idea. They suggest that the future of semiconductor manufacturing may become more spread out, more strategic, and less concentrated than before. So this is not yet a story of final victory. It is the story of a door opening. If India can turn policy into output, factories into reliable volume, and ambition into long-term execution, then the global chip map may begin to change in a very serious way. India is not just building factories. It is trying to build a new place for itself in the world's most important supply chain. And if this gamble works, the chip industry may never feel quite the same again. If you enjoyed this video, like, share, and subscribe for more stories on the technologies reshaping the future.